Now we have to discuss about redundancy protocols. So what is redundancy? What do you mean by redundancy?
So have more than one connection.
More connection?
One goes down, the another will take.
Kind of, we can say backup.
Yeah.
Okay. So that we do not have a single point of failure. Okay. So let's say, for example, let's consider an example that usually what is going to happen whenever you take an internet connection. Okay. So if you take an internet connection, we are going to give you a router. Correct. And then in the enterprise, what you're going to have? Switches. You're going to have switches, and with the switches, your hosts will be connected. Let's see. These are the hosts connected. Router will connect to the switch and it will connect you to the internet. Okay. This is your internet, or you can say ISP. Okay. This is your router. Let's say R1. Your switch. Then you have PC1, PC2, and then you have PC3, PC4. These are the PCs. Okay. Now, on these PCs, let's consider the IP addresses. This is 10.2. Okay. Now let's say 10.11. This is 10.12, 10.13, 10.14. Okay, these are the IP addresses. And on the router, let's say we have the IP address 10.1. Here, and this is ISP, so this side public network is there. Okay. Now, if you want to use internet, you will assign default gateway to these PCs. Correct. So what will be your default gateway? 10.1. So here also you'll assign 10.1 as the default gateway. Correct. To the PC2 also you will define 10.1. Here also 10.1. And also here 10.1. Correct. This is the default gateway you are going to define. So if you define 10.1 as the default gateway, what is going to happen? How your traffic will pass? Through 10.1. Because if your traffic has to go to the internet, it will pass through the gateway. So means, let's say PC1 is trying to access the internet, come to the switch, go here and then go this way. Correct. What will happen if your router goes down? No communication, your entire network is what? Down. Okay. In that case, we will need backup. So for backup, what we can do? What we can do for backup? We can use one more router for the backup. Correct. Let's use one more router. Let's say this is your backup router. Okay. In this one, let's say R2. Clear? And let's say you have assigned the IP address here, 10 dot. Clear? Now, what you will assign in the gateway? 10.1 or 10.2? 2? Okay, let's go and assign 10.2. So everywhere I'll assign 10.2. 10.2. 10.2. 10.2 and also 10.2. Done. Now, if I want to access the internet, what will happen? How my traffic will pass? Let's say from PC1 I'm trying to access through the switch, go to the R2, then go to the internet. What if my R2 goes down? What we have to do? We have to reconfigure the default gateway, and this time what we will configure? 10.1. Okay, let's go and change.
Sir, instead of adding one more router, we can add one more cable R1 interface.
So what? If your R1 is down, what is the use of the
router
cable?
is down.
Yes, total router is down. In that case, what will do?
We have to configure HSRP protocol,
Okay.
redundancy protocol. So they do.
Yeah, those protocols will study, but why we need those protocols, we have to understand. Okay. So what you'll do, you'll just go and manually configure here again. 10.1. 10.1. 10.1. 10.1. Now, what if your 10.1 is down? Again, right now, how many systems we have? 4 systems. We can assign, no problem.
We can give virtual default gateways.
Yes, I'm coming to that. Okay, please wait. What if there are 5,000 systems? You work in an enterprise, you work in a company, and there are 5,000 systems. Now, how many times you'll go and change the default gateway manually? There is a problem. Correct. Okay. Other than this, what we can do, we can also prevent from the entire network from going down. We can prevent entire network from going down. How? Like we can say that, okay, in half of my network, I'll use 10.1. And in half of my network, I can use 10.2. So now if any of the router goes down, whether R1 or R2, my entire network will not go down at least. At least my entire network will not go down. But still half of the network will go down. Means even if we are using 2 routers for the backup purpose, we are not even getting the backup. Okay. When we are using 2 routers, we are not exactly getting the backup. What we are getting, we can limit the number of hosts that will be affected if your router goes down. That how many nodes or how many systems will be affected. The number of systems that will be affected if a router goes down. See, if R1 goes down, only PC1 and PC2 will go down. PC3 and PC4 still have the connectivity. If R2 goes down, PC3, PC4 will not have the connectivity, but PC1, PC2 will have the connectivity. So we are not getting the backup. Okay, we are just getting an option that, okay, your entire network will not go down. Okay. So this is also not called redundancy. Redundancy means your entire network should be up and running, even if your one of the router goes down. Okay.
There is a backup for all systems.
Yes, should be for the all systems. Okay. So what we can do? We can use the redundancy protocols. Okay. So what are these redundancy protocols? Okay. So for redundancy, we use a protocol that is known as FHRP. For redundancy purpose, we use a protocol that is known as FHRP. And FHRP stands for first hop redundancy protocol. Okay, first hop redundancy protocol. What do you mean by the first hop? What is hop? That is the next hop, next router. First hop means first router. So when these PCs want to access the internet, what will be their first hop? Their gateway only. Correct. So first hop redundancy means gateway redundancy. Okay. So your FHRP is used to provide gateway level redundancy. Gateway level redundancy. That backup of your gateway. Okay. Under FHRP, we have three protocols. Number one, HSRP. Number two, VRRP. And number three, GLB. These are the three protocols that are present under your HSRP. I mean FHRP. Okay. Your HSRP stands for hot standby router protocol. Your VRRP stands for virtual router redundancy protocol. Hot standby. Okay. Virtual router redundancy protocol. And your GLBP stands for gateway load balancing protocol. Okay. These are the three protocols. This is clear. Now, HSRP and VRRP, these are kind of exactly the similar protocols. Okay. So you can see in HSRP and VRRP, there is an active standby pair. There is an active standby pair. Means at a time, only one router will be active and one will be remaining in the backup state. Okay, standby state. That means at the time, only one router will be in the active state. And will be forwarding the traffic. Okay. At a time, only one router will be in the active state and it will be forwarding the traffic. Now, when I say active standby pair, that doesn't mean that only two routers can be configured. Okay. For redundancy purpose, you can configure more than two routers also. Okay. So in case of HSRP, the active the active router is known as active, means the term used for active router is active. Okay. Then the backup is known as backup. Oh, sorry, the backup is known as standby. Okay, the backup router will be known as standby. And if you configure more than two, okay, in that case, the remaining will be known as candidate. Candidate. Yes. And if more routers are there, if more remaining are candidate. Okay. So if more routers are configured for redundancy,
That means if active router goes down,
standby will become active and a new standby will be elected. Okay. Then they will be known as candidate. Okay. In case of VRRP, the active router is known as master. And the remaining routers are known as backup. Okay, in case of VRRP, the remaining all the routers will be known as backup.
And tell us also, sir.
Yes.
Play back. Master and slave.
No, master and backup.
That's good. Oh.
Clear? Then your HSRP is a Cisco proprietary protocol. Okay. While your VRRP is open standard. Means VRRP will be supported in all vendor devices. HSRP supported only in Cisco devices. Similarly, your GLBP is Cisco proprietary protocol. Okay. And your GLBP, there is no active standby pair, all routers are active. Okay. In GLBP, all routers are active and forwarding the traffic. This is clear.
in GLBP every time load balance.
Yeah, that's why load balancing is happening because everyone is active. Okay. Then you can say the HSRP command starts with the word standby. Means for HSRP, we use the word standby. Okay. And for VRRP, we will use the word VRRP. Remaining everything is same with the HSRP and VRRP. Now these are not in our syllabus. There is no configuration for HSRP, VRRP, GLBP, or FHRP. Okay, but I'll show you the configuration for HSRP. Okay, since we are studying Cisco, right? Okay, and if you want more differences in between HSRP and VRRP, there's one more difference that in HSRP, preemption is disabled by default. Okay, what is preemption? We'll come to know once we study about that. And in case of VRRP, Preemption is enabled by default. This is clear. So these are some of the points you must know about the HSRP, VRRP, GLP. This is clear. Now see how we will be configuring. So these gateway level redundancy protocols, what they do, we will configure a virtual IP. Okay. So a virtual IP is configured. Now let me say for FHRP, a virtual IP is configured on all the routers. Okay, whatever routers you are configuring for redundancy purpose, on all the routers you will configure a virtual IP. Okay, same IP. Okay, and the same virtual IP, that is in short VIP. Okay, let me say virtual IP only, otherwise you'll get confused. The virtual IP is configured on the end host as their default gateway. Whatever virtual IP will configure, that IP will be configured as the default gateway. Okay. Then when the active router is forwarding the traffic, the IP will be remaining with the active router. As soon as active goes down, the IP will automatically shift to the standby. Okay. Now, for example, let's say here we are configuring the virtual IP. I'm configuring, let's say 10.1.1.1. Okay, this is the virtual IP I have configured on both these routers. Now what will happen? This 10.100 only I will use as the default gateway. Ten dot 100. Okay. Now what will happen? Let's say, for example, at present scenario, R1 is active. So this IP will remain with the R1. Traffic will pass like this. This is clear. Let's say due to some reason, R1 goes down. So how R2 will come to? So they will continuously communicate using multicast addresses. Okay, they will continuously be sending packets using multicast addresses, and the backup router will continuously keep track of the state of R1. As soon as this goes down, what will happen? This IP will automatically shift to R2. Now, how your hosts will come to know that, okay, now the IP is with the R2, not with the R1. We have to forward traffic through the R2, not with the R1. So for that purpose, your R2 will announce IP to MAC mapping using which packet? ARP request. How to announce IP to MAC, how to check for duplication. GR. Remember, there was a redundancy thing that used for the redundancy purpose. So it will generate a GR. It will say that, okay, now this IP is with me. So switch will make an entry that, okay, now I have that MAC address on this interface, and PCs will also make the entries in their ARP cache. Okay. And now instantly they will start forwarding traffic like this through the R2. Okay. This is clear. Right. Okay. Now let's consider the case of HSRP. Yes, they will communicate using not through multicast. Okay. Now see, what will happen? Let's say if we are talking about HSRP, okay, because we will be discussing specifically about HSRP only, okay, not in the syllabus, but still I'll show you. So in case of HSRP, we have the pair what? Active standby pair. Which pair we have? Means one router will be active and the second router will be standby. But how it will be decided that who will be active and who will be standby? How this thing will be decided? Okay, so there is an election criteria for active router. The election criteria is the first. Okay, let me just write it down. In HSRP, there is an active standby. Okay, so if we discuss about active router election criteria, okay, what are the election criteria? The first criteria is highest priority. Okay, and the second criteria is if the priority is tie. If the priority is a tie, like if by default both will have the same priority. Okay, in that case, highest IP address. Okay, they will check for the highest IP address, and the priority by default is 100. The priority by default is 100. Okay, so initially what will happen? R1 will have the priority 100. R2 will have the priority 100. Correct. Now highest IP address, this side we have 10.1, this side we have. Who is having the higher IP? R2. R2 will be active. This will be standby. Correct. So the entire traffic will pass through this. Correct. If the entire traffic is passing through this, okay, well and good. Now, if we consider the case when this goes down, what will happen? This will become active. Okay, your R1 will become active. And when you fix your R2, let's say now R2 is up and running, so it will not go back to active state, it will go back to standby state. Why? Because the preemption is disabled by default. The preemption is disabled by default. Is that clear? Now, what does it mean with the preemption? So preemption simply means that your high priority router, should always be active. Should always be active. Okay. Now consider the case. Let's say, for example, I have changed the priorities. Okay. Let's say for R2, I changed the priority to 110. And for this, I changed the priority to 90. Okay. So obviously this will be active and this will be standby. Okay. Now again, if we consider the case when this goes down. Okay, when this goes down, and also we will consider this time that the preemption is enabled, means we have given the preemption command. So this time we will consider preemption enabled. Now what will happen? If this goes down, obviously this will come to the active state and will forward the traffic. But as soon as you fix it up, okay, as soon as you fix this router and this comes up, it will take again your active state. Why? Because your preemption is enable, and this will automatically shift to standby. This is your preemption. So by default, it is disabled, but you can enable it. And if you enable preemption, your high priority router will always be active. This is clear. And if you want to manipulate that which router will be active, which router will be standby, what you can do? You can change the priority. Is that clear? This is clear? Okay. Now, how do you enable HSRP? So let's go to the lab and design this lab. Okay. And then what we'll do? We'll do the configuration. Clear? Noted? Anything? Want to note down? No?
How network admin will get to know that is down?
There will be a log. Log will be generated.
So there is also some command. Command says there's also.
No. By default, logs are generated. What are logs? See, when you give no shutdown command, you see the interface is up. You see something, right? That is a log only. Okay, so every time you make some changes, a log will be generated. So, that will when you will be using SNMP and all those protocols. That is it. Okay. But right now we haven't discussed about SNMP and anything, so just consider logs will be generated. Because see, in your networks, not only a single protocol will be working at a time. There will be number of protocols that will be working in a time at the same time. Okay, and let's consider this. Let's say this is your R1. This is your R2.
Multicast address frequently that checks both the R1 and R2.
See, multicast address is just the destination. The packet will be your FHRP packets or HSRP packets. The protocol will be using is HSRP. Okay. So consider they are upside, they are connected to the internet, because right now we are not consider it about the person. Okay. So we'll be using the network 10.1.1. This is the network we will be using. Okay. So here on this router, I'll assign the IP 10.1.1.1. And here I'll assign the IP 10.1.1.2. And here I'll assign 10.1.1. Let's say 10. And here we'll assign 10.1.1.11. Okay, these are the IPs we are going to assign. Now the virtual IP that we are going to assign. Okay. Now, whenever you assign a virtual IP, a virtual MAC address will also be assigned automatically.
That will be learned in switch.
Yes.
So from switch end, if we want to like identify which is the active router, we can.
That will be depending on the port, because on the ports in the MAC address table, you will have the entry.
Yes.
Okay.
So when R1 is active, we will see R1's MAC address and R2.
No. The virtual MAC address will be this only. See, in switches, what you can have with a single port, you can have multiple MAC address mappings. Okay, I'll tell you how. This is clear. Right now, let's do the basic configurations. Only we need to assign the IPs and all. See, HSRP configuration is very easy. Only 2-line configuration. No. Enable configuration terminal. Host name is R1. Okay, then interface 0 by 0. IP address 10.1.1.1 255.255.255.0, and then no shutdown. This is done. Go here on the R2. Enable configuration terminal, host name R2, interface 0x0, IP address 10.1.1.2. Then no check. Normal IP assignment, no special configuration. Go here. Ten dot one dot one dot 10, 255. 10.1.1.100. Your virtual IP will be used as the gateway. Okay. Same thing here. 10.1.1.11. 10.1.1.100. Here, this is the normal configuration, IP configuration we have done. Nothing's no special configuration. Okay. Now what we'll do the HSRP configuration. See, if you want to configure HSRP, just go to your client side interface. What is the client side interface here? Z0x0, and here also Z0x0. Now see. Global configuration mode. Go to the interface Z0x0, and then simply give the command standby 1 IP. And what is the virtual IP? Your HSRP configuration is done. Only one line configuration. One command. Same command you just go and assign to the other router also, R2 also. Okay. Go here. Interface Z0x0. Standby 1 IP 10.1.1.100. Same command I have given. And your HSRP is enabled here. Okay. Now in some time you will see the log that okay, one has become active and one has become standby. Now what is the thing with your packet tracer? The router you configure first, that will become active. So first I configured R1 as right. So R1 will become active. Second time I configured R2, so R2 will become standby. Okay, this is the thing with the packet tracer. Okay, but in the real scenarios, what will happen? Your high priority router or your higher IP address router will be the active router.
If we load the
Simply what?
We have not been assigned.
Huh?
You have not assigned any yet.
No need to sign. Nothing, no need to sign. They will automatically check. See, I'm giving no standby. And here also, let me see. No standby. Okay. Now what I'll do? I'll go here. And first I will configure here on the R2. So earlier R2 was what? Standby. Now let me go to R1 and try to configure. Now you'll see your R2 will become active because first I configure R2. See. So in the packet tracer, this will happen. In the real scenario, this thing will work. Okay. In the real scenarios, first of all, highest priority. If no highest priority, highest IP address. I'll tell you. Right now we are going with the default priority. Okay.
100.
Yes, 100. Let me show you. Now you have done the configuration. You want to check the configuration. Okay. So in the privilege mode command, show standby. See. Show standby on the interface Z0x0. There is HSRP group number 1. What is the state of this router?
active.
Active router. Okay. You see active virtual IP address. Correct. And also active virtual MAC address will be there. Okay. Then you see hello time 3 seconds. Means every 3 seconds they will be sending a packet to check whether the active router is active or. So every 3 seconds they are going to check. Then after, what is the by default state of the preemption? Who is the active router? Local means itself. Who is the standby router? What is the default priority? what is the priority right now and what is the default priority. This is clear. Okay. So right now your R2 is active, correct?
Load time function to multitask.
Yeah, through multicast. Okay. See, if you want to see, we can just go to the simulation mode. Okay. And let's try to edit the filters. Here is the HSRP. So if you wait, they will generate a packet, you see. See, 224002 HSRP version 1. Okay, so they will be using a multicast address like 22400. This is clear?
Multicast address the same for.
Yeah, both the routers. They will use the same multicast. Now see. Right now, R1 is in which state? Standby state. R1 is in the standby state. Now what I'll do, I'll go to R2 and I will shut down the interface. Interface 0 shut down. Now you'll see a log will be generated here and this router will change into active. See, automatically change to active state. So if it is changing to active state means obviously your R2 is down. Now even if your R2 comes up, okay, even if your R2 comes up, okay, this will remain in the active state and your R2 will go to the standby state. Okay. Now again, this is one more bug in your packet tracer. That preemption is disabled, still your R2 became active. You saw, right? Preemption is disabled. Do show standby. See, preemption is disabled, but still it is changing the state to active. Okay, so this is one more bug in your packet tracer. By default, it will not change. If preemption is enabled, in that case, it will change. Okay, this is clear. Then how do you change the priority and enable the preemption and all? Preemption you have to enable only on the high priority router. On the low priority router, you don't have to change. Okay. So let's say, for example, this R2 is R2, or let's say this time I want to create R1 as a high priority router. Okay. See, let's say on R1, I want to change the priority. So I'll say interface, again, the client side interface only 0 The command is standby 1 priority, and whatever the priority, let's say 110, more than R2. Then after you want to enable preemption, you will say standby 1 preempt. You see automatically change state to standby. Okay. And if you see do show standby, now this router is what? Active, having the priority 110. Okay. And you see now it is not saying default, now it is saying configured. And earlier it was saying default. This is clear. Only on the not on the active, on the high priority one. Whatever, wherever you configure high priority, there you have to enable preemption. Okay. And in case of VRRP, it will be enabled by default on all the routers. So whatever router you configure with the high priority, that will automatically become active. Okay. So now even if your R1 goes down, let's say, yes, only high priority. That is the preemption. So on R1, if I go and shut down the interface, then R2 should become active.
Yes.
Okay, wait for it. Now it is active. And as soon as this comes back up, this will again go back to standby. Okay. Now this will take some time because the switch protocols and all. Now see, R1 is active and R2 goes back to standby. So this is your preemption. So what are the commands For the HSRP configuration, you gave the command standby. Then you gave a group number here. Okay. So in this router, at least 6 groups you can create. Then you said IP and whatever virtual IP you configure. Okay.
Start by one at one is the group number.
Yes.
Group number maybe.
Not anything. There is a range if you see 1 to 6.
Both should be same.
Yes. Not 1 to 6, but total 4096 group numbers are there. 0 till 4095. Okay. And if you want, you can change the timers also. The hello and hold timers. Okay. Now see virtual IP. Then again, same thing, standby. Then you give the group number. Then you can say priority if you want to change priority also. And then whatever priority you want to assign here. Okay. So again, priority value also you can check. Standby 1 priority 0 till 255. Okay. Priority value. Then if you want to enable preemption, standby group number and then you can say preempt. But this command only on the active router. This command you have to do on the high priority router. Let me say only on high priority router. Okay. Clear. This is what your HSRP configuration.
And the high priority router, which will we decide ourselves also?
You will decide.
Yeah.
So you will give interface. Okay. And this interface will be your client side interface, or I can say local interface. Okay. Let me see client side interface. And this is all your configuration is for HSR.
Sir, if there is two routers, R1 and R2, and both have same bandwidth speed. That means R1 have gigabyte internet ports and R2 also. Here, and there is 4 PC.
Okay.
If I want to, suppose there is 2 PC. If I want to configure the HSRP like PC1 always go to the R1 and PC2 always go to the R2.
You can do
If
that.
we R1 goes the
Right now we have seen what active standby. HSRP you can configure it in a way as a active also. There is a active HSRP configuration also. But if you were in CCNP, then I would show you everything. Okay. According to CCNA, even this is extra. Okay. In the active, see, let me tell you theoretically what you will be doing. Let's say these are 2 PCs or 4 PCs, or let's say you have 4 PCs, then you have 2 departments. Now for 2 departments on the switch, what you will do, you will create 2 VLANs. Okay. Now for VLAN 1 means this is a different network, this is a different network. You will create 2 sub interfaces here. Okay. Now again, you don't know what is sub interface. Okay. But consider like you will split this interface into 2 interfaces. Same split this interface into 2 interfaces. So basically what you will be doing, See, VLAN and all these we haven't discussed. Kind of you will divide it. Okay. Here, let's say 10.1.1.1 at the same time 20.1.1.1. Here 10.1.1.2, 20.1.1.2, like this. Okay. So for 20 network, I would make this one as active because high priority. Okay. And for 10 network, I would make this one as active. So this would be standby. This would be standby. Now what will happen? If there is a traffic from 20, this will go through this side. If traffic is from 10, it will go through this side. So this kind of configuration you can do. Since both routers are acting active at the same time, so this configuration is known as your HSRP active configuration. You can do that.
In what scenarios when this will this redundancies if, for example, client side interface goes down, then it will be kind of a
No, even if your entire router goes down, still will come up.
that is the scenario.
Yes, that is the true scenario. Okay.
So we need to check if any interface, if this active standby got changed, then we need to like check for any.
See, usually what you will be having a syslog server also. So there continuously the logs will get recorded. So either you'll see through the logs. If you are using SNMP protocol in the network, then it will generate alert and you'll get the alert. So somehow you'll come to know. Okay. But these protocols we have to discuss yet. Okay. This is clear. You can do such kind of configuration, but right now, according to CCNA, you don't need to worry about these things. Okay. This configuration is clear, right? Okay. Now let's go and check about your presentation. What is FHRP? FHRP means first of redundancy protocol used to prevent network failure at default gateway. This is achieved by configuring multiple routers with the same IP address, thus presenting an illusion of single router to the host. So according to the C, according to your host, according to these, only we are configuring this default gateway. So they will never come to know that, okay, there are 2 routers, 3 routers, or 10 routers. Because according to this, the PCs, there is only one default gateway, means one router. Okay. The IP address of the virtual router is configured on all hosts in that network or subnet as their default gateway. The virtual IP we are configuring as the default gateway. Then these are the 3 protocols: HSRP, VRRP, and GLP. Then this is small introduction to your HSRP. Is a Cisco proprietary protocol, enable the network engineer to configure multiple redundant routers that exist on the same subnet and can be used gateway for the devices on the subnet. We can use both the routers as the gateway, but without HSRP, what will happen? Each of the devices on the subnet would need to be individually configured to use a specific gateway, either 10.1 or either 10.2. Okay. Effectively not providing redundancy, but limiting the number of clients that would be affected if a router were to go down. So if you give, let's say, all PCs are using 10.1 and your R1 goes down, entire network is down. If all are using 10.2 and your R2 goes down, entire network down. If half of the systems are using 10.1, half of the systems using 10.2, and any of the router goes down, half of your network goes down. So it is not providing redundancy, but limiting the number of clients that would be affected. Okay. With HSRP, what is happening? A group of routers will be configured together and a single HSRP virtual IP address will be created that are used by the devices on the subnet. We created a virtual IP 10.1.1.100 and the same IP was used as the gateway, right? The different router in the HSRP will communicate to select a single active gateway that handle all the live traffic. So all the routers, they will communicate and they will select one active router, highest priority or highest IP. At this point, a single standby gateway is also elected. So if one router is becoming active, automatically the second router will be standby. This standby gateway communicate with the active gateway via multicast 224002 and will detect should the active gateway fail. So it will continuously keep track of your active router. And if your active router fails, then what will happen? It will automatically change the state to active. So when this happens, one of the standby gateway will take over the duties of the active gateway and continue forwarding the traffic without much delay. Okay. When this happens, again, a new standby gateway will also be selected. Then these are the protocols, HSRP, VRRP, GLBP, active, standby, and then this is candidate, master, backup, and in the case of GLBP, okay, you will have AVG, AVF, AVF, active virtual gateway, active virtual forwarder, but all the routers will be in the active state. Then these are some of the differences that, okay, what is the full forms of these? Then you have active, standby, master, backup, and AVG and AVF. Then they will use virtual IP addresses, your HSRP, Cisco proprietary, VRRP, open standard, GLBP, Cisco proprietary. In case of HSRP, how the active router, higher priority, higher IP address, high priority, higher IP address, high priority, higher IP address. Okay. Tracking, so they will keep on tracking that, okay, active gateway is up or down. Okay. Preemption, in the preemption feature is available everywhere, but in case of HSRP, it will be disabled. In case of VRRP, it will be enabled by default. Timer adjustments, you saw the command standby 1 timers, and you can adjust the timers also. And these are the multicast addresses that they use. So you see 224.0.0.2, this one we saw, right? And then your VRRP will use 224.0.0.18, GLBP will use 224.0.0.102.
Sir, HSRP is Cisco proprietary.
Hmm.
VRRP
Open standard.
open standard, it is support
Oh.
Cisco device.
Yes. Okay, not in the packet tracer, but in the real devices, you can see. Okay. This is clear. Small introduction to your HSRP, and we saw the configuration.